Good morning. This is your stats sensei, Mr. Spensei, and today we're going to review the empirical rule and also take a look at central limit theorem in a warm up and an exit ticket. The exit ticket will have the central limit theorem. So IQ scores are normally distributed with a mean of 100 and a standard deviation. Label the mean and standard deviation as well as the z-scores. Be certain to include the percentages associated with the empirical. So let's start off with our z-scores. So starting off with z-scores, the mean is 0 for all z-scores. And we just count up 1, 2, 3, -1, -2, and -3. And by empirical rule, that's 68%. Plus or minus 2 is 95%, and plus or minus 3 is 99.7%. All right. They told us the actual mean was 100. And in this case, we're supposed to have a standard deviation of 15. So I know that's left off of this, but we're changing by 15 because that's the actual. So there we go, which means we're just adding one standard deviation to be at 115. This will be at 130. This will be at 145. Taking away 85. Then we're down at 70. Now we're at 55. What percent of IQ scores are within the interval 55 to 150, 55 to 145? Well, that's plus or minus 3 standard deviations. So that's just our 99.7%. What percent are within the interval 70 to 130? That's plus or minus 2. So that's 95%. And what percent of IQ scores are within the interval 85 to 115? Well, that's 68%. And then what percent of IQ scores are above 100? Well, remember the normal curve is symmetric and mound shape, which means the mean and the median are equal. So that means that if the mean is here, that's where the median is also. And 50% of data is above the median and 50% is below. So we know that this is going to be 50% on this side and it's 50% on this side. And they said what part is above 100? So 50% is above our mean of 100 or above the median of 100. The next thing is, how likely is it to a randomly selected individual have an IQ score greater than 120? So they want to know the probability that X is greater than 120. So probably ought to draw a little picture of that. So here's our mean, 100, our standard deviation. And then our actual value of 120. And remember, mean of 100, standard deviation of 15. We're going to do a little norm CDF. Norm CDF, lower bound 120, because that's the lowest part of our shading. The highest part of our shading is positive infinity. Our mean is 100, and our standard deviation is 15. So lower, upper, mean, standard deviation. And I'm going to go ahead and add the negative infinity and the positive infinity to my drawing up there that I left off. So going to the calculator, we're going to go to a second vars. So second vars, normal CDF, lower bound 120. Upper bound, there's not an infinity key, so 9 caret 99, 9 to the 99th is large enough. Mean is 100. Standard deviation is 15. And we end up with about 9%. So 0.0912 have an IQ greater than 120. So there's about a 9% chance that an individual will have an IQ greater than 120. Here's the drawing one more time. Appreciate you watching this morning and hope to see you on the next one. Thank you.